Hi everyone! In this video, we're going to learn how to find the arc length of a curve using calculus. And we're going to practice 10 questions. Let's start with the arc length formula. If f prime is continuous in the closed interval a to b, then the length of a curve y, which is f of x, from a to b is integration from a to b of square root 1 plus f prime of x squared dx. Here, instead of f prime of x, you can use dy over dx, which is technically the same thing. And if you're calculating the arc length with respect to y, then instead of f prime of x, you're going to use f prime of y with respect to dy. And you can substitute f prime of y to dx over dy, which is the first derivative of the function. If you would like to know more about the geometric interpretation and how this formula is derived, you can watch my other video. Now we're going to start example 1. Example 1. Before solving example 1, I would like to remind the preps. So this type of question require these ingredients. We need to find the first derivative of the function, we need to square the first derivative, and we need to add 1 to the first derivative's square. Let's start. So we need to find the first derivative of the function. Here we can apply the power rule. So what was the power rule? We bring power to the front and subtract 1. So 3 over 2 x minus 1, and we're going to subtract 1 from the power. You can choose 1 as 2 over 2, and let's clean up. So 2's cancel out, 3 times x minus 1, and 3 over 2 minus 2 over 2 is 1/2. So this is the first derivative of the function. Now we're going to square this quantity. So 3 times x minus 1 raised to the 1/2 will be squared. 3 squared is 9. And x minus 1 raised to the 1/2 squared is x minus 1. You can think it like this. X minus 1 raised to the 1/2 is square root of x minus 1. And if you take the square of this, square root cancels out square and you get x minus 1. Now we're going to distribute 9 to the x minus 1. So 9 times x is 9, and 9 times 1 is 9. So this is the square of the derivative of the function. Now we're going to add 1 to this quantity. So 9x minus 9 plus 1. So what we're going to get is 9x minus 8. So this is our 1 plus f prime of x squared, which we are going to use in our arc length formula. So we can set up the integral. What was the integral? Length equals to integral from a to b square root of 1 plus f prime of x squared dx. Okay, so integral from a to b. In our case, our a is 1 and our b is 5. So from 1 to 5, integral from 1 to 5, square root of 1 plus f prime x squared is, we calculated here, 9x minus 8 dx. So this is our integral setup. Now we're going to calculate this function from 1 to 5. we're going to get the antiderivative of this function and compute the boundaries. So here we can apply u substitution. We can pick u 9x minus 8. So this is our u. So what's going to be du? Du is the derivative of this function. Derivative of 9x is 9 and derivative of constant is 0. So du equals to 9 dx. And if we solve for dx here, we're going to get 1 over 9 du. Now let's write in terms of u. So integral from 1 to 5, square root of u. Instead of dx, we're going to write this quantity because this is equal to dx. And we can pull 1/9 to the front and du stays here. Let's clean up. We can write square root of u in exponential form. So 1 over 9 integral from 1 to 5 u to the 1/2 du. Now it's easy to take the antiderivative of this. We can apply the power rule. 1/9 is in front. When we take the antiderivative, we add 1. So u to the 1/2 added 1. You can choose 1 as 2 over 2. And we're going to divide by whatever the power is, which is 1/2 plus 2 over 2. So what we get is 1 over 9 u to the 3 over 2 divided by 3 over 2. So divided by 3 over 2 means multiplied by 2 over 3, keep change flip. So let's rewrite it. 1 over 9 times 2 over 3 u to the 3 over 2. Okay, let's put u back and multiply this. This is going to be 2 over 27. What is u? U is 9x minus 8 raised to the 3 over 2. Calculated from 1 to 5. Now we're going to plug our upper boundary and lower boundary. Okay, we have 2 over 27 here. Let's start here. 2 over 27 in front. We're going to plug our upper boundary here. So 9 times 5 minus 1, minus 8. Raised to the 3 over 2 minus our lower boundary. What is our lower boundary? 1. 9 times 1 minus 8 raised to the 3 over 2. 2 over 27 is in front. 9 times 5 is 45. 45 minus 8 is 37. 37 raised to the 3 over 2 is 37 root 37. You can think it like this. Any number, let's say a, raised to the 3 over 2. You can rewrite this as a times a to the 1/2. Because power is here 1, or you can write 2 over 2. 2 over 2 plus 1 over 2 is 3 over 2. So a to the first power is a times a to the 1/2 is square root of a. So anything raised to the 3 over 2 is like a square root a type of term. Here in our case, it is 37. So 37 root 37. Okay, minus our lower boundary. 9 times 1 is 9, minus 8 is 1, 1 raised to the anything is 1. So this is our final answer. You can leave it here or you can go ahead and calculate the decimal point. We're going to leave it here for this question. Let's go to second example. In the second example, our function is square root of x, and we're going to find the arc length from 0 to 2. And actually here we're going to set the integral to find the arc length only. We need to find the first derivative of the function. The derivative of square root of x is 1 over 2 times root x. If you don't know that by heart, you can use the power rule. Square root of x is x to the 1/2. And according to power rule, you can bring power to the front and subtract 1 from the power. 1/2 minus 1, which is 2 over 2, will give you x to the negative 1/2. And if you make that power positive, you need to put x to the bottom. So it's going to be 1 over 2 times square root of x. Now we're going to square this quantity. 1/2 squared is 1/4, and square root of x squared is just x. Now we're going to add 1 to this quantity. 1 plus 1 over 4x. Our ingredients are ready, so we can go ahead and write down arc length formula. Integral from a to b, in our case from 0 to 2, square root of 1 plus f prime of x squared dx. This is the arc length formula. Now we're going to plug in our 1 plus f prime of x squared, which is this quantity we calculated above. So integration from 0 to 2 square root of 1 plus 1 over 4x dx. So this is the integral to calculate the arc length. This is our final answer. If you need to calculate the arc length, you can use necessary integration techniques and calculate the boundaries from 0 to 2. So this is our final answer here. In the example 3, we are going to set the integral to calculate the arc length from 0 to 2. So our function is x cubed. We're going to find the first derivative of the function. We can use the power rule. Bring the power to the front and subtract 1. Now we're going to square this quantity. 3 squared is 9, and x squared squared is x to the 4th. Now we're going to add 1 to this quantity. 1 plus 9x to the 4th. Our ingredients are ready, so we can set the integral to calculate the arc length. Integral from a to b, in our case from 0 to 2, square root of 1 plus f prime of x squared dx. We know what 1 plus f prime of x squared because we found it here, and we can substitute it. Integral from 0 to 2, 1 plus 9x to the 4th. So this is our integral to calculate the arc length from 0 to 2. This is our final answer for this question. Let's go to example 4. In the example 4, we're going to set the integral to find the arc length of f of x from 0 to 3. First, we need to find the first derivative of the function. The derivative of 1 over 6x is 1 over 6 plus the derivative of 1 over 2x is negative 1 over 2x squared. You can consider it like 1/2 times 1 over x. And derivative of 1 over x is negative 1 over x squared. And if you multiply with 1/2, you get negative 1 over 2x squared. Or you can use the power rule. 1 over 2x can be rewritten as 1/2 to the x to the negative 1. And you can apply the power rule. Bring the power to the front and subtract 1 from the power. So negative 1 times 1/2, if you bring it to the front, gives negative 1/2. And if you subtract 1 from negative 1, it will be negative 2. And you need to put negative x to the negative 2 to the bottom to make it positive power. So negative 1 x to the 2. So you get the same results. So the derivative of f of x will be 1 over 6 minus 1 over 2x squared. Now we're going to square this quantity. This is binomial expansion. You can consider it as a minus b term squared. So a minus b squared is a squared minus 2 times ab plus b squared. In our case, our a term is 1 over 6 and our b term is 1 over 2x squared. A term squared is 1 over 6 squared, which is 1 over 36. A times b is 1 over 12x squared times 2 is 1 over 6x squared. Plus b term squared. 1/2 squared is 1/4 and x squared is x to the 4th. So we get 1 over 36 minus 1 over 6x squared plus 1 over 4x to the 4th. Now we're going to add 1 to this quantity. So adding 1 to that quantity is adding 36 over 36 to this quantity plus 1 over 36. So here we get 37 over 36. And we can rewrite all of them as 37 over 36 minus 1 over 6x squared plus 1 over 4x to the 4th. So our ingredients are ready, so we can set the integral. Integral from a to b, in our case from 0 to 3, square root of 1 plus f prime x squared, which is 37 over 36 minus 1 over 6x squared plus 1 over 4x to the 4th dx. So this is our integral to calculate the arc length of f of x. So this is our final answer for this question. Let's go to example 5. In the example 5, the length of a curve from x equals to 1 to x equals to 4 is given by integral from 1 to 4 square root of 1 plus 9x to the 4th dx. The curve contains point 1, 6. What's the equation of the curve? This time we are going to find the equation of the curve. In the arc length formula, integration from 1 to 4, 1 plus 9x to the 4th this term is our f prime of x squared. So can we find f prime? Yes, if we square root this quantity, then we can find f prime. So 9x to the 4th square root will give us 3x squared. So now we know that our f prime is 3x squared. Because our f prime x squared was 9x to the 4th. And our 1 plus f prime of x squared was 1 plus 9x to the 4th. If our f prime is 3x squared, can we find our f of x? Yes, the antiderivative of the f prime will give us f of x. So antiderivative of this, we can apply the power rule, add 1 divided by the power. So it's going to be 3x cubed over 3, and 3 is cancelled out, so our f of x is x cubed. Knowing that our f of x is x cubed, we can find the equation. Our equation will be x cubed plus some constant. We know that our function passes through point 1, 6. If we plug in this point, we can find the equation. So our f of x is our y coordinate, 6, and our x coordinate is 1. So 1 cubed plus c. 6 equals to 1 cubed is 1 plus c. Here, if we solve for c, subtract 1 from both sides, so c will be equal to 5. If we put everything back, our function will be x cubed plus 5. We put c back. So our final answer for this question is x cubed plus 5. Let's go to the next example. Example 6. We're going to find the arc length of ln cosine of x from 0 to pi over 4. First, we're going to find the derivative of ln cosine of x. Ln cosine of x, you can consider it as ln of u. So the derivative of ln of u is 1 over u times u prime. Here our u is cosine of x. So what is the derivative of cosine of x? So u prime will be negative sine of x. So if we put everything here, 1 over cosine of x times negative sine of x will give us negative sine x over cosine of x. And we know that sine over cosine is tangent. So we have negative sine here, negative tangent of x. So we can go ahead and write down the derivative is negative tangent of x. Now we're going to square this quantity. Negative tangent of x squared will be tangent squared of x. Now we're going to add 1 to this quantity. 1 plus tangent squared of x. We know that Pythagorean identity 1 plus tangent squared of x will be secant squared of x. We can add it here in our key. 1 plus tangent squared of x is secant squared of x. This is Pythagorean identity. So we can set the integral. Our integral from a to b, in our case from 0 to pi over 4, square root of 1 plus f prime x squared, which is secant squared of x. Dx. Integral from 0 to pi over 4. Secant squared of x goes out of the radical sign as secant x. The square cancels the square root. Dx. Now we're going to find the antiderivative of this function and compute the boundaries. Integration of secant x is our classical integrations, so you need to know this by heart. Integration of secant x is equal to ln of secant x plus tangent x. So ln of secant x plus tangent x evaluated from 0 to pi over 4. So we plug our upper boundary, which is ln of secant plus tangent. Our upper boundary is pi over 4. Minus our lower boundary, ln of secant plus tangent. And our lower boundary is 0. Here we know that tangent 0 is 0. Actually, let me draw a unit circle so it will be better to see that. In our unit circle, our interest is 0 and pi over 4. 0 is here, and the coordinates of this point is 1, 0. The x-coordinate is our cosine, the y-coordinate is our sine. And in the pi over 4, which is 45 degree, 1 over root 2, 1 over root 2. The x-coordinate is our cosine, y-coordinate is our sine function. Tangent 0, tangent is sine over cosine. 0 over 1 is 0. Secant 0 is, secant is 1 over cosine. And 1 over 1, which is the cosine, will be 1. So secant 0 is 1. Tangent pi over 4. Tangent is sine over cosine, and 1 over square root 2 divided by 1 over square root 2 is 1. So tangent pi over 4 is 1. And secant pi over 4, Secant is 1 over cosine. So 1 over square root of 2 is square root of 2. So 1 over this fraction will flip. So if we simplify, we're going to get ln of root 2 plus 1 minus 1 plus 0 is 1 ln of 1. And knowing the logarithmic rules, we know that ln of 1 is equal to 0. So our final answer is ln root 2 plus 1 for this question. Let's go to next example. In this question, we're going to set the integral to find the arc length of f of x from 1 to 2. First, we're going to find the derivative of the function. Derivative of x is 1 minus, we have 1x in front of ln of x, and the derivative of ln of x is 1 over x. If we simplify, we're going to get 1 minus 1 over 8x. Now we're going to square this quantity. This is our binomial expansion. This is like a minus b term squared. And you can apply the formula a squared minus 2 times ab plus b squared. In our case, our a term is 1 and our b term is 1 over 8x. A squared is 1 squared, which is 1, minus a times b is 1 over 8x times 2 is 1 over 4x, plus b term squared is 1 over 8 is squared 1 over 64, x squared is x squared. So our f prime of x squared is 1 minus 1 over 4x plus 1 over 64x squared. Now we're going to add 1 to this quantity. So it's going to be 1 plus 1, it's going to be 2. So 2 plus 1 over 4x, 2 minus 1 over 4x. Plus 1 over 64x squared. Now we can set the integral. Our integral from a to b, in our case from 1 to 2, square root of 2 minus 1 over 4x plus 1 over 64x squared. Dx. So this is our integral to calculate f of x. This is our final answer for this question. Let's go to next question. Question number 8. In this question, we're going to find the arc length of cosh x from 0 to 1. First, we need to find the derivative of cosh of x. The derivative of cosh of x is sinh x. Now we're going to square this quantity. So it's going to be sinh squared of x. And now we're going to add 1. So 1 plus sinh squared of x. We know the Pythagorean identity, 1 plus sinh squared of x is equal to cosh square root of x. So we can set the integral from 0 to 1 square root of cosh square root of x dx. Integral from 0 to 1, cosh square root of x goes out of the radical sign as cosh. Square cancels the radical sign. So cosh of x dx. Now we're going to find the antiderivative of this function and calculate the boundaries. Antiderivative of cosh x is sinh x. So sine hyperbolic of x calculated from 0 to 1. Now we're going to plug our upper boundary minus lower boundary. So sinh of our upper boundary minus sinh of our lower boundary. Our upper boundary is 1 and our lower boundary is 0. We know that sinh 0 is equal to 0. So our answer is sinh of 1. You can leave your answer here, or you can go ahead and calculate sinh of 1 using the sinh function. What was the sinh function? Sine hyperbolic of x equals to e to the x minus e to the negative x divided by 2. And here you can plug 1 instead of x. So it's going to be e to the 1 minus e to the negative 1 divided by 2. And e to the 1 is e minus 1 over e divided by 2. Again, you can plug in your calculator and you can find the decimal point. It's going to be approximately 1.175. Question number 9. Set the integral to calculate the arc length of y from -1 to 1. First, we're going to find the derivative of the function. So we can apply the power rule, bring the power to the front, and subtract 1 from the power. So 2 over 3 minus 1. 3 over 3 is minus 1. So what we get is 2 over 3 x to the negative 1/3. And if you rearrange that, it's going to be 2 over 3. You can bring this to the bottom, make the power positive. So cubic root of x. Here we can realize that our f prime is undefined at x equals to 0. So we cannot use this derivative for that. So what's going to be our strategy? Our plan is to use symmetry and going through inverse function. So if we measure from 0 to 1 the inverse function, which is symmetric to this half and exactly the same length, and multiply this quantity by 2, we can calculate the arc length of y. So let y inverse be g of x. So what is g of x then? G of x is the inverse function of y. So how do we find the inverse function? Y equals to x to the 2/3. When we are finding the inverse function, first we switch x and y. and we solve for y. So how can we isolate y here? So we need y alone. We need to multiply the power by the reciprocal, 3 over 2, and we have to do the same here, 3 over 2. So what we get is x to the 3 over 2 equals to y. So it's going to be x to the 3 over 2. If g of x is x to the 3 over 2, what is g prime of x? So we can apply the power rule again, bring the power to the front, and subtract 1. So 3 over 2 minus 1 will be 1/2. Now we're going to square this quantity. G prime of x squared. 3 over 2 squared is 9 over 4. And x to the 1/2 squared is x. Now we're going to add 1 to this quantity. Now we can set the integral for this red line. So integral from 0 to 1, square root of 1 plus 9 over 4x dx. And if we multiply this whole quantity by 2, which is the other side, plus this side, that will be equal to the length of arc length of y. So this is going to be our final answer for this question. This is how we can find the arc length of y. Let's go to the last question of this video. Question number 10. Find the arc length of ln secant x from 0 to pi over 4. First we need to find the derivative of ln secant of x. You can consider it as ln of u. And derivative of ln of u is 1 over u times u prime. Here our u is secant of x. So what is u prime? U prime is secant x tangent x. And if we write it here, 1 over secant x times secant x tangent x. Here, if we simplify, secant x cancels out and it's going to be equal to tangent x. So our derivative is tangent x. Now we're going to square that quantity. It's going to be tangent squared of x. And we're going to add 1 to that quantity. Here you can realize that this is Pythagorean identity. 1 plus tangent squared of x equals to secant squared of x. Now we can set the integral. Integral from 0 to pi over 4 square root of 1 plus f prime x squared, which is here secant squared of x dx, equals to integral from 0 to pi over 4 secant squared of x goes out of the radical sign as secant x. Here, square cancels the square root. So our integral is from 0 to pi over 4 secant x. Now we're going to find the antiderivative of this integral and calculate the boundaries. So integral of secant x is one of our classical integrals that you need to know by heart. So it equals to ln of secant x plus tangent x. So ln of secant x tangent x evaluated from 0 to pi over 4. We're going to plug our upper boundary minus lower boundary. Our upper boundary is pi over 4 and our lower boundary is 0. Tangent 0 is equal to 0. Let me draw the unit circle so it will be easier to see here. Our interest is to find 0 and pi over 4. Okay, the coordinates of 0 is 1, 0, and coordinates of pi over 4 is 1 over root 2, 1 over root 2. X coordinate is our cosine, y coordinate is our sine. So tangent is sine over cosine. At 0, sine is 0, cosine is 1. 0 over 1 is 0. So tangent 0 is 0. Secant is 1 over cosine. At 0, cosine is 1. 1 over 1 is 1. So secant 0 equals to 1. Tangent pi over 4. Tangent is sine over cosine. At pi over 4, sine is 1 over root 2 and cosine is 1 over root 2. Anything divided by itself is 1. So sine over cosine is 1. At pi over 4, secant is root 2 because secant is 1 over cosine and 1 over root 2 will be root 2. So if we simplify, it's going to be equal to ln of root 2 plus 1 minus ln of 1 plus 0 is 1. We know the logarithmic rules that ln of 1 equals to 0. So this is 0. So our final answer is ln square root 2 plus 1. This is the final answer for this question. This is the end of whole video. Thank you for watching.